Hi, welcome to Cherry Pie Math. Today we're going to be talking about variables and why we use them so much in mathematics and where they come from. So to start off, we're going to look at these pictograms here. I want you to pause the video and see if you can figure out what each spool of yarn is equal to and what the needle is equal to. So go ahead and pause. Okay, hopefully you paused it. If not, and you just want to hear what the answer is, that's totally fine. So at this point in time, there's not a lot of algebraic manipulation that we know of yet, so it'll be mostly guess and check. An easy number to start with is the number 1. So if we say that each one is equal to 1, that would mean that this whole part is equal to 3, which means that this part would be equal to 3, the needle here. So let's check if that works. So 3 minus 1 is equal to 2. That's true. So the yarn is equal to 1, and the needle is equal to 3. And that'll make our equations true. So throughout the rest of this unit and throughout most of your mathematical journey, really, and even past high school and past college, just in your daily life, you're mostly going to be trying to find what number you're missing, and that's where variables come in. So we use variables as placeholders. Actually, all right, they are placeholders for unknown values. So for example, let's say you're trying to throw a party and you know that you have 40 people coming. You would maybe say, like, I need X amount of pizzas to feed everybody, because you don't actually know how many. Later you can solve for it. You can find out what X is equal to. But the letters, the variables themselves, are just placeholders for numbers that we don't know what they're equal to yet. So the most common variables you're going to see are X, and often I'll write my X kind of like this, but honestly you can just write it as like a normal X. Y is a really common one, and you'll often see them kind of in pairs. Sometimes you'll see Z. I usually write my Z's like this because otherwise to me it looks like a 2. Other groups of letters you'll see are like A, B, C together, or you'll see M and N together, or you'll see R and S together, maybe T. Often you'll see groups of letters that are right next to each other, but these are the most common ones, with X and Y being the most common of them all. And of these two, even X is your most common one. So X is the most common variable. The other ones kind of follow through. Okay, to solve for a variable means to find out what that variable is equal to. And we usually write these as like X equals to a number or whatever it is. So like the variable equal to the number. And when I'm teaching, I actually dock points if you don't write it like this, because if you just say the answer is 3, like, that doesn't tell me. It does tell me that you knew how to solve it, but 3 is just a number. But if you say X equals 3, then I say, oh, okay, so 3 means that letter. Everywhere it says X, it really means 3. So I'm really picky about that. It depends on your teacher, but I'm picky about it. To simplify is very similar, but simplifying means to contract it as much as possible. Maybe contract is the wrong word. Maybe let's say condense. So you want to squish it all together. So solving means to find out what the letter is equal to, whereas simplifying means to condense it as much as possible. So like 4 plus 5, it's a lot easier to say 9. 9 is simplified. 4 plus 5 means the same thing, but it's not simplified. So let's solve for these variables. And remember, solve means to find out what X is equal to. And we always, or A or Y or whatever that letter is. So in this first one, 5 plus X equals 7. We know that 5 plus 2 equals 7. That means X is equal to 2. Or in this next one, 9 plus X equals 3. 3 is less than 9. That means that X has to be a negative number. We know that 9 minus 6 equals 3. So that means that X is equal to negative 6. And the next one, 3 times y equals 27. We know that 3 times 9 is equal to 27, so y equals to 9. And then finally, 8 divided by a is equal to 2. We know that 8 divided by 4 is equal to 2, so a equals 4. That's all it means to solve for the variables. It means to find out what number would go into the place of that letter that we don't know yet. So let's try rewriting that initial equation. Let's call these yarns x and the needles y. So in the first equation, it's 3x plus y equals 6. And the second one is y minus x equals 2. And I want to pause here for a second. I could have written x plus x plus x. But I didn't. I wrote it as 3x because why on earth would I write it 3 times when I could just write 3? Maybe when it's just 3, it's okay, but eventually you're going to be doing this with like 102x. You don't want to write x 102 times, so you write the number of times it appears, and then you write the letter. So let's actually go over that a little bit more. So 6 and 2 in this case, so I have 6x plus 2y equals 10. These are both called coefficients. And you'll see this word a lot. Coefficients mean the amount of times you see that number or that variable. X and y are both variables. And then 10 is the solution, I guess. It's what it all equals to. So coefficients always come right in front of that number there, or the letter there. And I'm actually going to zoom in on this a little bit. I know I don't zoom in on these videos a whole lot. Notice that there's nothing in between them. It's just 6 and then it's x. It's saying the x appear, if I was to write it out, I would see it 6 times. I just needed to check something. So if I was to rewrite this, it would be x plus x plus x plus x plus x plus x plus y equals 10. But again, I don't write it all the way out. I just write 6x, and really that means 6 times x. Even though I don't write the times, it's still technically there because it's saying it's that many times, and timesing is just adding it together that many times. So when a number is in front of the variable, we call it a coefficient. We multiply a coefficient by the variable because it represents the amount of the variable we are combining together. If there's no coefficient written, like sometimes it'll just say x or y, we assume that the coefficient is 1. And then sometimes it helped my students to put a 1 in front of the letter just to remind themselves that that is the coefficient that you're using. So let's practice writing it. This first one we have 3 acorns, so let's just use a. And we have it 3 times, so we would say 3a equals 9. Or in this next one, I have 2 airplanes, so I would write 2a, and I have a minus a backpack. So let's call that b. We're subtracting only 1. So I don't have to write the 1. I can if I want to. Like, this is not technically incorrect, but it's not very pretty. So when it's just 1, we just keep it like this, and we would just say 2a minus b equals 9. So later on, if I was looking at this, I'd say, oh, there's no number in front of the b. That means that there's an invisible 1 there, because we always assume the coefficient is 1 if we don't see it. So let's practice simplifying a little bit. We're going to use x equals 3 and y equals -2. And remember, we are multiplying them. We multiply the coefficients by the variables. So I can write them in like this. 5 times 3 plus 2 times -2, and that's what we're trying to find. And remember, with simplifying, we always use PEMDAS. So I'm going to multiply first, so that's 15, and that's -4, and I'm adding them together, which gives me 11. So that's my answer there. In this next one, I have -3, and again, I always multiply it by my variable. My x is 3. My y is -2. This becomes -9. This becomes -8. -9 plus -8, it becomes -17. And if you want to go over these, I talked about this in an earlier video about how to use PEMDAS. This one we have 7, and we're multiplying it by... Also, by the way, you don't have to write the dot. You could also just use parentheses. So I can do 7 and then parentheses 3. And this is the same thing as saying 7 times 3. You'll see this later as well. And then my y is equal to -2. I know that subtracting a negative makes it a positive. So later on, it's going to be 21 plus 4, which is equal to 25. And then finally, I have this one. My x is by itself, so the coefficient is 1. I can just write the 3. I could write 1 times it if I wanted to, but I don't have to. And then -2 times -2. And again, when you have a negative times a negative, that becomes a positive. So it's equal to 7. So all I did was I put in what I knew the variables were going to be. I put it into there and I multiplied it by the coefficients, and then I added or subtracted them together. So some food for thought. Why are variables useful? Like, I know I personally actually really love variables because, like I said, writing x 100 times is so annoying. And sometimes students will do it. Their minds have a hard time grabbing hold of like the quantity of the x's, and so they do write out every single x, and that's fine. And it just takes forever. So I really like having variables because it makes us able to skip over the like boring stuff of math and get into the interesting stuff. So if to someone that was scared of variables, I would say as you get further in math, because variables, we're able to do much cooler things, and we can do so much cooler things, and it does get easier because once after this class, you're basically going to be using variables forever. So that's what I would say. There's not really a right answer, so just think about it. So some things to remember from this lesson: coefficients are multiplied by the variable they are attached to because they show the amount of that variable present. Solving means to find what the variable is equal to, whereas simplifying is to condense it as much as possible. And variables don't need to be scary. They're really just like symbols. Honestly, you could draw a picture of like an acorn if you really wanted to, but like no one uses that in the real world, so we just use X.